Hi class, today we will be going over an AP problem that involves simple harmonic motion. A spring that can be assumed to be ideal hangs from a stand as shown above. Question A asks, you wish to determine experimentally the spring constant K of the spring. First part asks, what additional commonly available equipment would you need? Second part, what measurements would you make? And the third part, how would K be determined from these measurements? And so if you go to the AP sheet with all the equations on it, a few equations pop into mind, and we are looking for one with the spring constant. And the one that is, the first one comes up is the force of the spring is equal to negative kx, where Fs is the force of the spring, k is your spring constant, and x is the distance. Your string is either stretched or compressed, and it'd be easier for us to stretch a spring rather than to compress it because it is easier to measure that way. And so the force of the spring is also equal to mass of the object that you'll be attaching to the bottom of the spring times gravity. Now gravity is a constant that is 9.8 meters per second squared, or approximately 10 meters per second squared. And so for this lab, the equipment we will need is an object whose mass is known, and we will need something for measuring distance the spring is stretched. And so something like a ruler or a meter stick would be all that is needed. And so measurements you would make are the mass of the object you'll be attaching. You'll need to measure that, and you also need to measure the distance the spring, my bad, is stretched. And so from these measurements you can plug them back into the equation and set mg equal to negative kx. And when you move stuff around, you get k is equal to negative mg over x. And so you plug in your figured out x, your measured x into here, and your measured m into here, multiply by gravity, divide by distance times negative sign, and you get your spring constant. And now let's move on to part B. Part B states, assume that the spring constant is determined to be 500 Newton per meter. A 2 kilogram mass is attached to the lower end of the spring and released from rest. Determine the frequency of oscillation of the mass. And so this problem wants to know what is the frequency of the mass. And so from our chart of equations we get that the period is equal to 1 over the frequency. And since we are dealing with springs, there is another equation that says the period of a spring is equal to 2 pi times the square root of the mass over the spring constant. And so from these two equations we can substitute Ts for 1 over F. And so we get 1 over F equals 2 pi times the square root of m over k. And if we move stuff around, we end up getting that the frequency is equal to 1 over, the frequency is equal to 1 over 2 pi times the square root of m over k. And since pi is a variable, all we need to know are the mass and the spring constant, which they handedly give us. And so you plug them into equation, and so the mass was 2 kilograms, and the spring constant was 500 Newton per meter. And so this comes out to be approximately 2.5 hertz. And a hertz is just 1/2. But either notation works, and you shouldn't be counted off when you're doing this AP problem if you put hertz or 1/seconds or seconds to the -1. As long as you get the right unit on it, you are good. And so this leaves us with part C. Suppose that the spring is now used in a spring scale that is limited to a maximum value of 25 newtons. But you would like to weigh an object of mass m that weighs more than 25 newtons. You must use commonly available equipment and the spring scale to determine the weight of the object without breaking the scale. So the first part asks us to draw a clear diagram that shows one way that the equipment you choose could be used with the spring scale to determine the weight of the object. The second part asks, explain how you would make the determination. So one obvious method comes to mind is that we shall use the same stand as before. So this is our stand. I'm not going to label it, but on the AP test you should. And we will use our spring with the scale. And then we will also be needing our mass again for this one. We will be needing a beaker of water. And that is all we will be needing. So we will still need our stand. Stand, scale, beaker of H2O. Okay, and so this is a very poorly drawn picture of our diagram and the mass. Of course, can't forget the mass. And so to determine we are trying to determine the weight of the mass, which is m. And so from this we know that water has a density of 1 gram per milliliter. So we can figure out how much water we put in the beaker originally and the volume of the amount of water we put in the beaker, and then once we attach the mass to the spring scale, we drop the mass slowly into the water until the buoyant force acts upon it. And so we will then find the measurement of how much water is displaced, the volume of the water displaced, and we will know that the amount of the mass of the water displaced is equal to sum of the mass of the object. And so we also know that the spring scale will be pulled to its limit at 25 newtons, but it will not break because it is just at 25, and the amount of water will help us to know the rest of the mass. And so when we add the 25 newtons to the rest of the mass found by the displacement of water times gravity, we will be able to figure out the total weight of the object. And that is how you would finish part C. And that is how you figure out that AP problem and all its parts. Thank you for watching this video.